So, first, I want to talk about this concept of geometric mean. Okay? So,
Let's just put that header there. Geometric mean. Now, if I say take the mean of two numbers, what does that mean?
the average. Okay? So, most of the times, if I went ahead and said, find the mean of 4 and 6, under normal circumstances, you would say 4 plus 6 and divide it by the number of terms, and that would give you 5. And that's the average. That's the mean of them. Okay? But this is what they call an arithmetic mean. Okay? Which means that we're going to add them and divide by 2. When we do geometric mean, we're going to multiply them together and then take the square root of it. So the geometric mean of 4 and 6 is the square root of 24. And when we reduce this using perfect squares, we get 2 square root of 6. Okay? So when I say the geometric mean of two numbers, I am multiplying those two numbers together, and then I'm simplifying it. We're taking the square root. Now, let's say that I have something like this. The square root of x plus 6 equals 9. How do I solve for x? No? I have the square root of, I can't do that yet. I gotta get rid of this square root. How do I get rid of the square root? Huh? No, because it already is here. So you remember how if I take this, if I square a square root, it cancels it out? Remember that? Possibly? Okay. Well, if you square a square root, or take the square root of a square, they cancel each other out. So in order to get rid of this radical, I'm going to square it. If I do it over here, I have to do it over here. So I have x plus 6 equals 81. So therefore, in this case, x would equal 75. You're going to have to remember how to do this, okay? Because when we get into this next section, I need you to know, I need for you to know how to simplify or solve for a variable this way. All right. So, under normal circumstances, I would do a lot more of this. Oh my God. All right. So let's.
So,
Remember what the altitude of a triangle is? The height of it. Okay? So if I have a triangle, right? And I want to find the altitude of it, I would take from the opposite vertex, I would draw a perpendicular line. That's the altitude. Okay? So in this case, if we start off with a right triangle, this is my right triangle, F, G, H. Okay? And I put an altitude in this, GJ. Alright? I connected the vertex to the opposite side to the right angle. Okay? Then I can create proportions. Now we're not going to go into proportions here, but let me go ahead and label this side X Label this side y, and label this side z. Okay? So, we're going to do geometric mean. If I want to find this altitude, and you can remember these rules. If I want to find z, z is the geometric mean of whatever x and y is. So if I say this is 4 and this is 6, then z would equal the geometric mean of 4 and 6. Which we already said was 2 square root of 6. Alright, so let's look at an example on this. Alright, so we had E. Now this is going to be the triangle we're going to use to kind of reference a lot of this. So E is going to equal the geometric mean of 6 and 24. We're not going to solve this yet. Now understand, this is my altitude, and we're taking the geometric mean of these two parts. Now, if I come over to D, D is going to be the geometric mean. See this small triangle right here? 6 belongs to that small triangle. So 6 and D belongs to this larger triangle. So this 6 and this whole side here, 30. Okay? And then C is equal to the geometric mean, again, part of this triangle right here is 24. And C is also part of the longer triangle, the larger triangle. So 24 and 30. Okay? That is this lesson right here. Okay? That's what you have to remember. E, the geometric mean of these two parts. D, the geometric mean of its part and the whole thing. C is the geometric mean of its part and the whole thing. You can remember that, and this lesson is done for you. Okay? It's a matter of simplifying from here. Now, your numbers generally will not be as big as these, so I'm not going to get into simplifying these numbers right. Alright? But we want to look at some examples here. Alright, so understand that if I'm looking at this triangle right here, and I want to solve for this. Alright, this we're just solving for one variable. So if this whole side right here is 25, then this part is 16. So, not that I wouldn't know that, because x is equal to the geometric mean of its part, 9, and the whole thing, 25. Now some of these become really easy, because the square root of 9 times the square root of 25 is the square root of 9 times the square root of 25, which gives me 3 times 5, 5, which equals 15. Alright? Now, I want you to try this one. Find x for me.
right, so in this case, we would say that x is equal to the geometric mean of 9 and 16, which would be the square root of 9 times the square root of 16, which would give me 12. Okay? You okay with that? All right. You good? Okay. All right, so let's do this one. Now, we're going to do this one together. All right? So here, again, the rule is this is equal to the geometric mean of this and this. So 12 is equal to the geometric mean of 9 and x. This is where I wanted you to remember how to solve for the x in this case, because now in order to get that square root gone, I'm going to take the square of both sides. All right, this square cancels the square root, and I have 9x equals 144. From start to finish? Okay. All right, so the rule was this altitude, just like over here, when we looked at this first one, actually, if I look at this right here, we said that, well, x was equal to the geometric mean of these two numbers, 9 and 16. You agree? Okay. So then, let's go over to this one. The same thing happens. This is equal to the geometric mean of these two numbers. So 12 is equal to the geometric mean of 9 and x. Okay? So in order to solve for this, I'm going to square both sides, because this square cancels the square root. And so now on this side, we have 9x. Over here, we have 144. No, because this square took care of this square root. They canceled each other. Okay? So therefore, we have 144 divided by 9, and that's going to give me 16. Okay? All right. So looking at that, I want you to find, so let's look at this right here. We'll work on this one together as well. Let's do the setup here. The setup is this side right here was equal to the geometric mean of its part and the whole thing. Let's do it again. 15 is equal to the geometric mean of its part to the triangle, that small triangle that it belongs to, and the big triangle that it belongs to, which is x. So therefore, when I set this up, I'm going to say 15 is equal to the geometric mean of its part in that small triangle, 9, and its part in the larger triangle that it belongs to, which is now x. Okay, so what do I do now? I don't square root, I square. Square both sides. So I'm going to square this side, and I'm going to square this side. So now I have 9x by itself equals 225. And so therefore, I get x equals 25. All right? You guys do this one. All right, so you should have set this up as 12 is equal to the geometric mean of the two parts, 16 and x. So therefore, when I square both sides, 144 equals 16x, and that would give you 9. So x equals 9. All right, let's do one more and I'll cut you loose. All right, let's look at this for a second. We already know that 48 is equal to the geometric mean of this part and this part, right? But I don't know this part. Does anybody know this part? Well, does it make sense that it's whatever the whole is minus the part? So let's just say x minus 64. Now go ahead and set it up. So let's make sure the setup is correct at least. 48 would equal the geometric mean of these two parts, 64 times x minus 64. Okay, that's the setup. Now, in this case, when I square both sides to get rid of this square root, we're left with 2,304 equals 64 times x minus 64. Now you have two choices. You can distribute this 64. I personally don't like to distribute. If I can, I will just divide the 64 to both sides. So then I would get 36 equals, because these two cancel now, x minus 64. Does everybody see what I did? You'll get the same answer either way, whether you distribute it or not. But all of a sudden, when you distribute it, you just work with larger numbers, and if I can avoid doing that, I will. So at this point, I will add the 64 to both sides, and x equals 100. Okay? All right.